Hello, we are CE Squared Engineering, and this is our design presentation for a wildlife overpass on Highway 8991 in Wellsville Canyon between Brigham City and Cache Valley. Our team consists of senior civil engineering students at Utah State University, including myself, Camden Gillens, Ethan Scow, Eduardo Guaramo, and Carson Winger. Our team was interested in designing a wildlife crossing, so we reached out to Pam Kramer with the Northern Region of the Utah Division of Wildlife. Pam was very helpful with assisting our team in identifying an area where a new wildlife crossing is warranted. She told us that the stretch of Highway 8991 in Wellsville Canyon near mile marker 8 in the small town of Manaway was an area of frequent vehicle-wildlife collisions. The high speed limit, substantial traffic volume, and mountainous nature of the terrain, combined with the fact that the highway crosses through a major wildlife migration route, results in vehicles and wildlife frequently coming into contact. There are several existing underpass crossings in the area, but they have been mostly ineffective due to the dark and confined spaces that these crossings present to deer and other large wildlife. Because wildlife tends to avoid using the existing crossings, they are left with no other way to get across the highway besides crossing in front of oncoming traffic. Our team presented and examined 4 possible alternatives to reduce vehicle-wildlife collisions through Wellsville Canyon. These alternatives were evaluated, and the recommended alternative was selected and designed by CE Squared. Our design is intended to allow wildlife to safely cross Highway 8991 to preserve animal life, as well as to increase safety for travelers on the highway and reduce the cost of the vehicle-wildlife collisions. Ethan will now speak more on the alternatives our team considered.
So the first alternative we considered was enlarging the culverts in the area. As Camden mentioned, there are several underpasses in the area that are underperforming. In fact, one of these underpasses is one of the most underperforming wildlife crossings in the state. And as Camden said, this is likely due to their dark and cramped conditions. So instead, one alternative is to tear out the old culverts and install a new, larger one. This would allow for larger animals like deer to cross safely and feel more safe in the environment. These culverts can even be installed with lighting. This would, however, require us to tear out a section of the road and could take considerable time in constructing. The second alternative we looked at was a prefabricated bridge. This would be similar to the bridge in Figure 2. This overpass would allow for animals of virtually any size to pass over Highway 8991. This would be built with prefabricated parts that would be shipped to the site and built and constructed to reduce time construction as well as costs. These prefabricated parts would mostly be the arches as well as the MC wall parts. The arch bridge would be covered with soil, and the MSC wall would retain the soil. The bridge would also allow for vegetation for cover, so the animals will find it more enticing to use as a crossing. The third alternative we looked at was a design bridge. This design bridge would look similar to the highway overpasses over regular highways. This would require the bridge to be fabricated on site and require more construction time. This bridge would also have a soil cover, but would only allow for smaller vegetation. It would be similar to an existing wildlife bridge located near Park City. And the fourth option we looked at was the do nothing option. This would be the cheapest, but also would have no effect on increasing wildlife safety. Next, Eduardo will talk about our selected alternative.
Based on the decision matrix, we decided on the prefabricated overpass bridge design. The enlarged culvert scored low on impact on traffic during construction, The design bridge scored essentially the same as a prefabricated design, but ended up costing more. The do nothing alternative scored the worst in overall cost. This is because there would be no decrease in vehicle deer collisions. Also, the Utah Division of Wildlife has placed a price on the life of a deer, so the state would essentially lose money every time a deer was involved in a vehicle collision. The prefabricated design scored high marks in least impact on traffic during construction, second only to the do nothing alternative. The prefabricated design is the second most expensive alternative behind the design bridge at an estimated cost of $3.19 million. The prefabricated bridge was favored because it would be the easiest alternative to build. Also, in a real-world situation, we would have to specify the specs of the bridge, like the concrete strength and soil strength, and send those specifications to a company like Contact to build the components using their models and our specs. For our situation and our project, we had to design the bridge for whatever alternative we ended up choosing. And I'll pass it over to Carson to speak about the design.
The design of our project is based mostly off of the Bevo arch system. There are 3 overpass sections: the foundation, the stem walls, and the arch. The foundation will be the cast in place component, and everything else will be precasted and transported to the site in 8-foot sections. The overpass will have a soil surface to simulate a natural crossing by using small vegetation. The dimensions of the arch structure is 100 feet long, 86.5 feet wide, and 30 feet tall. Due to the landscape of the surrounding terrain and the need to have a natural transition to that landscape, the total structure is a little over 300 feet wide. The poster shows a similar structure that is in Banff National Park in Alberta, Canada. There is also a profile view of our proposed design. Some of the difficulties we had was trying to decide how to fit the crossing to the surrounding landscape. We first did not understand the width or the height that would be required, and it was not until we used a DEM, or a digital elevation model, that we really understood what was going to be needed to complete the project. Another difficulty we had was designing the arch and the MSC walls. These are both elements that no one in our group had experience doing and was kind of a time-consuming task. We also did not have much of an understanding of how elements tied together, and that was something that took some time to work through. Learning the software can also be a difficult task. One major thing that can contribute to a positive experience on these projects is group chemistry. Our group had great communication and usually worked on things together. I would recommend taking a similar approach due to creating a positive learning environment and not feeling on your own when learning new things. We would like to extend a special thanks to our external PE, Kyle Dana, from Forest Green Associates, our faculty advisor and professor, Austin Ball, and our client, Pam Kramer and Scott Walker with the Utah Division of Wildlife Resources. And then also a special thanks to Joe West, who helped with our group for 1 semester. Thank you for your time.